Hello, welcome to a brief before the lecture video. It looks like most people in the ESE13 section have at least logged into Blackboard. Just remember that you have two pretests, a pretest for Chapter 2, a pretest for Chapter 4, and then a post-test for Chapter 2 due on the 10th, so on Wednesday. So make sure you get those done before lecture starts. And I'd like you to, when you're viewing this tonight, just go ahead and watch this and think about a few of the concepts that I think will help you understand why we're going over plate tectonics in Chapter 4. So let me pull up one of the key overarching concepts. So why do we learn about plate tectonics? It's a geologic theory that says parts of the crust are created at mid-ocean ridges, and then parts of the crust are destroyed through subduction. And basically, the book never says it exactly, but we will be talking about the Wilson cycle. And so I just wanted to go over that really quickly. Watch it tonight. And then when we talk about it on Wednesday, hopefully you'll understand why we're putting so much emphasis on plate tectonics. So on Earth, the oceans have not always been here. And the oceans that we see today aren't the ones that were here 3 billion, 2 billion years ago. In other words, oceans, just like humans, they have a developing, a baby stage, a midlife stage, a declining, and ultimately a terminal stage of their development. And that's what we call the Wilson cycle, which you see on screen here. So the idea is you have a couple of continents like North America, South America, and Africa all joined together. And there are a bunch of little cracks that go through. And then due to changes in how the mantle, that's the second layer, below the crust, how that hot material moves around, it can force heat to the center cracks of where these continents have all come together. And that material then starts bubbling up new lava in between these continents and start pushing them apart by introducing new material into the center of those cracks, and the cracks get wider, the new material cools, it cracks, and more lava is pushed up in between. And this is a denser material, as we'll cover in lecture, so it sinks lower in the mantle, and basically the lowest parts, you can see the continents on either side are higher. The lowest part then fills in with water, and so this is the beginning stage of an ocean, and here is where an ocean is actually filled up with water and is starting to grow, because as you can see, both plates, or the continents, are moving away from each other as new magma and lava cools and forms a mountain chain in between that's growing out in either direction. And then eventually what happens is this new material becomes so cold and dense that it is able to slip underneath, break apart, slip underneath the continent. At that point, although the ocean is still growing at the middle, the end is being destroyed or consumed, and it's sort of like wrapping up a rope, pulling it in hand over hand. One side or both sides are now being pulled in faster than they can let the rope out, and so the continents start coming back together. And so this would be the declining, mature declining phase of an ocean, right down here in number 3. And then finally, one plate will be completely consumed, and you have the terminal phase. And when all that ocean material in between has been pushed underneath the continents, they come back together, and you get back to a bunch of continents together. And so this entire thing is called the Wilson cycle. And it's estimated, I mean, it's not perfect for every ocean, but it is estimated that the Wilson cycle takes, 500 million to 800 million years to go from when the continents split apart to ocean development to ocean declining to finally the ocean is completely consumed between the two continents as they come back together. So that's the Wilson cycle, and that's why we're looking at plate tectonics, is that we understand how oceans started, how oceans develop over time, and how they go away, because what stage the ocean is in has a lot of consequences for how salty it is, for what's around it, like the fact that the Pacific Ocean has all these volcanoes all around the edges is explained by where it is compared to the Atlantic Ocean. So we look at these things in order to understand where things are in terms of the Wilson cycle. And the other thing is you can actually see this evidence in Google Maps in the ocean that we've mapped. And you talked about how we mapped things last time. If you notice this mountain chain we talked about last lecture, this is the spot where the Atlantic Ocean is growing. So it's spreading and getting wider. As new material fills in this mountain range here, it pushes Africa away and Europe away from North America at about the rate your fingernails grow. And so this is the youngest part of the Atlantic Ocean. And you can see that this mountain range kind of follows the pattern of North and South America and the bulge in Africa. The mountain chain was where these two continents used to sit, right here, when there was no Atlantic Ocean between them. And all this material here has been growing away from the mid-ocean ridge as new molten rock cools in the mountain range, and it then is split by new rock, and new lava flows in and pushes that rock further and further apart. So this is the youngest part of the Atlantic Ocean, and by contrast, when we look at the rocks over here at the edges of the Atlantic Ocean and the edges here around Africa, these are where the older rocks are, and they're about 150 to 200 million years old. Now, how is that compared to the continents? Continents are billions of years old. In fact, some parts of the center of Canada, we've measured their ages at 3.7 billion years old. The oldest ocean rocks we find are only 200 to 300 million years old at most. And so plate tectonics helps us explain that as well. There are similar things going on. There are similar ridges, but they're not spreading as quickly in the Pacific Ocean. So here's a ridge that is growing, but it's really small now. There's a little bit of a ridge still growing along here, but it's almost all completely been subducted under South America and North America. And when you look at these really black, deep trenches, the deepest parts of the ocean are over here and here for the Pacific Ocean. They have completely consumed the edges of that were once the Pacific Ocean, and the spreading center even is being pushed underneath North America and South America. So the Pacific Ocean is getting smaller and smaller now all the time as the Atlantic Ocean pushes North and South America over the Pacific Ocean plate. And same thing is happening on the other side as you push Africa, Eurasia, Australia over the Pacific Ocean plate. So the Pacific Ocean is in a declining phase. Even though it's the largest right now, in 50 million, 100 million years, that won't be the case. The Atlantic Ocean will be about the same size as the Pacific Ocean, and eventually the Pacific Ocean, if everything continues, will go away, while the Atlantic Ocean will then be the largest ocean on the planet. So hopefully that helps explain why we spend so much time in this chapter looking at plate tectonics.